Hello, everyone. In this lecture, we talk about similar triangles. Let's first see similar triangle situations. The first situation is parallel. So when you have a triangle and you have a line parallel to the base, we will have triangle ADE, the small triangle similar to triangle ABC, the big triangle. Another parallel situation is like when AD parallel to BC and you have AB and CD intersect at E, then you will have triangle ADE similar to triangle BCE. So the top small triangle, you should to turn it around, turn to turn to 180 degree. Then you can clearly see they are similar. Another situation is right triangles. So here, for example, we have triangle ABC and we do a height perpendicular. You will have 1, 2, and the original big triangle. Those three triangles, they are similar with each other. Another situation is from a random point D, you do a height perpendicular. You will have the newly formed triangle CDE is similar to the original one ABC. Okay, now let's see some real questions. The first one comes from 2020 10A 12. Let's pause the video and think about it. Okay, let's take a look. So triangle AMC is an isosceles with AM equal to AC and the median MV and CU perpendicular. So this is perpendicular. And the median, so these two are middle point. And the MUCU is 12. What's the area of AMC? So first, very naturally, we will connect U and V. And because these two are middle point, we will have UV parallel with MC. So the triangle AUV is similar to the big triangle AMC. And since AU is half of AM, so the area of triangle AUV to triangle AMC, the ratio will be 1 over 4. So we know this is 1/4 of the big triangle. Okay, which means the bottom part is 3/4 of the triangle ABC. And the bottom part, it's it's a trapezoid with two diagonal. They are perpendicular. So this one, we can actually calculate the total area with, so basically this line is 12. And these two adding together is also 12. So it's actually 12 times 12 divided by 2, which is 72. And the 72 is equal to 3/4 of triangle AMC. So AMC is 72 divided by 3/4. That is equal to, this is 24, 96. The next question comes from 2018 10A, problem 13. Let's pause the video and think about it. Okay, let's come back. So here we have a triangle 3, 4, 5. And point A is folded so that A falls on point B. So we know the creaser must be in the middle point of AB, and it's folded like this with A, B. And let's say if this point is D, and AD will replicate with BD. Okay. So here the question is, what is, let's say this is O, what is OD? Let's assume this is X. And you can see this is perpendicular, which means the small triangle is similar to big triangle ABC. For small triangle AOD, we know this is 2.5. So let's take this out. It's 2.5, similar to a triangle that is 3, 4, 5. and we want to know what is x. So you can see x must be 2.5 divided by 4 times 3, which will be 2.5 is 5 over 2 divided by 4 times 3, which will be 15 over 8. Okay, the next one comes from 2019 10B, problem 16. Let's pause the video and think about it. Okay, let's come back. So we first need to draw this graph. We have a triangle that right angle at point C and ACDE. Okay, point D lies in the interior of AB and the E lies in BC. So E is here, D is here, so that AC equal to CD and DE equal to EB. Okay, so DE equal to EB. So this is point B. And AC is 3, DE, AC is 4 to 3. So this is 4 and this is 3. Okay, what's the ratio of AD over DB? So let's just assume this is 4 and 3. And we know this is a right angle. And this angle 1 equal to this angle 1. This angle 2 equal to this angle 2. And we know angle 1 plus angle 2, they are 90 degree, which means this angle 1, angle 2 adding together is 90 degree. So this is actually a right angle. So angle CDE is a 90-degree angle. So now we can use Pythagorean because this is 4, this is 3, which means CE should equal to 5. Okay, this is our first step. So it seems we need to do it like this, do a height. And this is 3. So this small triangle should be, if we take this out, this is 3. It's similar to the big triangle with the ratio of 4, 8, and 4, 8 is actually similar to a base triangle with 1, 2, root 5. So this is the 1, 2, root 5 triangle. And so if this is 3, we're going to find out the other two sides. So one side will be 3 over root 5. The other side is 3 over root 5 times 2. So let's simplify this. This will be 5, 3 root 5. And this is times 2. So it's going to be 6 over 5 root 5. So now that we find, let's say this is O. OB is 6 over 5 root 5. And this is also 6 over 5 root 5. So this is D. We know now we get BD is equal to 12 over 5 root 5. And we know AB. AB is actually 4 times root 5. So if we do the minus, AD will equal to AB minus BD, which will be 8 over 5 root 5. So AD over BD will be, the ratio is 8 over 12. So this one over this one. Those can be cancelled. So 8 over 12, which is 2 over 3. Okay, the next question comes from 2016 10A, problem 19. Let's pause the video and think about it. Let's first draw the shape. We have rectangle ABCD, and the AB is 6, BC is 3, so this is 3, BC, so A, B, C, D, this is 6. Point E in between B and C, such that BE equal to EF, so BE equal to E. So this is 1, 1, 1. Segment AE and AF intersect BD at P and Q. This is Q. The ratio BP, PQ, QD is RST when the greatest common factor is 1. So they have no common factor. What is RST? So this one, we can also use similar triangle. So here we can see, let me draw this one. So if I draw this red one, these two red triangle, they are similar to each other. So we're gonna have BP over BD. The ratio is 1 to 3. So we can say if we assume BD is 1, if we assume BD equal to 1, then BP will just be 1/4. Okay, and then let me use a different color. So now that we have a green one, we draw it green. You can easily see these two green triangle, they are similar to each other. So now we will have BQ to QD should equal to 2 to 3, which means we can say BQ is 2/5 of 1. Okay, so now that we have BP is 1/4 and the BQ is 2/5, which means PQ is 2/5 minus 1/4, which is 23. So now we have BQ and the PQ, and the DQ will just be 3/5. So now we can do the ratio. So this ratio is actually equal to 1/4 over 320 over 3/5. So we have 2 times 20 with everyone. So this becomes 5 over 3/12. And those three, they have no common factor. So this is 5, 3, 12. And the total will be 20. Okay, let's see the next one. This is from 2017 10B, problem 15. Let's pause the video and think about it. Okay, let's first draw this shape. A rectangle ABCD has AB equal to 3. So A, B, C is 3, 4. Point E is a foot of perpendicular from B to diagonal AC. So this is E. Okay. What's the area of AED? This one is relatively easy. So this is perpendicular. So we know AC is just 5. And BE, the length of BE, we can use area. So that the area of the triangle is 3 times 4 divided by 2, which will equal to 5 times BE divided by 2. So BE will equal to just 12/5. BE will be equal to 2.4. So this is 2.4. And then AE. AE, this is a similar triangle. We know AE over BE should equal to 3/4. Since BE is 2.5, so AE will be 1.8. And the EC will just be 3.2. So the area of AED, we can say the area of ACD is equal to 3 times 4 divided by 2, which is 6. And triangle AED, the area will just be 6 times 1.8 divided by 5. That's a base ratio. So it's going to be 6 times 9/5 divided by 5 is 54/25.